Hello everyone, welcome to my YouTube channel. Myself Naveen Khan, currently studying in Sri Venkateshwara College of Engineering in BMW section. Today we will discuss about the topic the parameters of animation involving concepts of physics. So starting from the physics of animation, the physics animation, also known as physically based animation, is a computer graphics technique that uses physical principles to create realistic movements and interactions for objects. It's used in video games, movies, virtual reality, and simulations. Physics animation uses principles like gravity, friction, and collision detection to create believable motion. It can depict a variety of phenomena, including fluid dynamics, cloth simulation, and soft body dynamics. Physics animation is used because it can create natural and believable motion without the need for manual keyframing. However, it's often limited to loose approximations of physical behaviors because of time constraints. Fundamental forces in animation. Firstly, we will discuss about gravity, then move on to friction and drag. So, starting from gravity, the force that pulls everything towards the center of the earth, giving objects weight and causing them to fall. And moving on to friction, the force that opposes motion between two surfaces in contact, causing objects to slow down or stop. And lastly, drag, the force that opposes motion through a fluid, such as air or water, slowing down objects like falling leaves or swings. So in this slide, we will discuss about Newtonian mechanics and animation, in which we will discuss about Newton's first law, second law, and third law. So starting from Newton's first law, an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force. Moving on to the Newton's second law that states the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. And lastly, Newton's third law, for every action there is an equal and opposite reaction. Simulating gravity and acceleration. This involves three steps. And the first step is understanding the constant downward acceleration due to gravity is key to stimulating realistic falling motions. Moving on to the second step, use acceleration to create realistic bounce animations for characters and objects. And then adjust gravity to create exaggerated or subtle movements based on the animation style. Modeling mass and momentum. Mass. The amount of matter in an object affects how it responds to forces, influencing its acceleration and momentum. And then momentum, a measure of an object's motion equal to its mass multiplied its velocity, determines how much force is needed to move the object. Incorporating friction and drag. Friction. The force that opposes motion between surfaces in contact affects how objects slow down when sliding or rolling. Drag. The force that opposes motion through a fluid, such as air or water, affects how objects slow down when moving through the air, like a falling feather. Exploring collisions and impulses. Elastic collision, inelastic collision, and impulse. Starting from elastic collision. Collision where kinetic energy is conserved, objects bounce off each other with minimal energy loss. And then inelastic collision. Collision where kinetic energy is not conserved, objects deform or stick together, losing energy as heat or sound. And then impulse. A change in momentum can be used to stimulate the heat and force. Animating rotational motion, angular velocity, torque and angular momentum. Angular velocity, the rate at which an object rotates, determines how fast it spins. Torque, a force that causes an object to rotate, used to control the spinning of objects like wheels or propellers. And then angular momentum, a measure of an object's rotational motion, influences how easily an object rotates and how much force is needed to change its rotation. Advanced techniques, fluid dynamics. Fluid dynamics is a branch of fluid mechanics that studies the movement of liquids and gases. The study of the movements of gases and their interactions with moving bodies is usually called aerodynamics, whereas the study of liquids is called hydrodynamics. What is the main principle of fluid dynamics? The basic fluid mechanic principles are the continuity equation, the conservation of mass, the momentum principle for conservation of momentum, and the energy equation. And moving on to the conclusion, the art of realistic animation. By understanding the fundamental principles of physics, animators can create believable and immersive animations that transport viewers to new worlds. That was all for today's topic. Thank you.